What if the Earth we thought we knew is only half the story? Picture a compass spinning not out of miscalibration, but because the very fabric of the planet's magnetic skin is shifting beneath it. This isn't the plot of a science fiction film. It's a documented reality. Earth's magnetic north, once inching predictably across the Arctic, is now racing toward Siberia at speeds never before seen. Since the dawn of the new millennium, the pole's pace has quadrupled, forcing even military-grade navigation systems into emergency recalibrations. And the south magnetic pole? It's accelerating too, in the opposite direction. Across the globe, anomalies like this are surfacing, not once in a generation, but in synchrony, in increasing frequency. Ocean currents that reverse direction against the laws of physics. Atmospheric rivers that rain down over deserts with moisture levels inexplicable by meteorological science. Lightning storms erupting in cloudless skies. These are not isolated oddities. They are seismic shifts in the way Earth behaves. And they don't fit inside the neat boxes of conventional climate science. Each of these phenomena defies long-held assumptions about how our planet works. The models we use to predict weather, climate, even navigation, are beginning to show cracks, and not small ones. They reveal a world operating according to rules we may have misunderstood or never known at all. These events aren't just statistical outliers. They represent something deeper, something far more mysterious. Scientists are observing, documenting, and struggling to explain. Some anomalies, like the weakening of Earth's magnetic shield, carry implications that ripple into space weather, solar radiation, and atmospheric chemistry. Others, like the Gulf Stream's spontaneous reversals, hint at hidden forces influencing oceanic motion from thousands of feet below, or even from beyond. But what do these changes mean for us? Beyond the data and instruments lies a human question. For centuries, we've built our understanding of the world on the premise of predictability, that the Earth follows certain patterns governed by physics, chemistry, and time. Yet what happens when those patterns dissolve? When ancient rhythms no longer hold? When ice melts and refreezes without reason, and the sky floods deserts with oceans of vapor? This story is not about apocalypse or conspiracy. It is about humility, the recognition that our knowledge, as vast as it feels, is still dwarfed by the complexity of the Earth itself. Perhaps in seeking to control nature, we've overlooked its deeper truths, truths that now rise up through shifting soil and magnetic storms. This series is a journey into that unknown. 14 chapters, each peeling back a layer of reality, inviting us to look again at what we thought we understood. From the depths of the oceans to the upper reaches of the Ionosphere, we will explore 10 of the most confounding environmental mysteries known today. Not to seek easy answers, but to feel the wonder of the questions themselves. Because sometimes the Earth whispers in riddles. And sometimes, if we listen closely enough, we begin to hear them. It started with a needle that wouldn't sit still. For centuries, Earth's magnetic field has been our silent guide, a cosmic force aligning compass needles, protecting our planet from solar radiation, and steering migratory creatures across vast distances. But something has changed. In recent decades, the magnetic North Pole has begun a sprint, racing from Canada toward Siberia at speeds exceeding 40 meters per year. That's nearly 4 times faster than at any point in recorded history. This isn't just a curious quirk. It's a transformation that has forced emergency updates to the world magnetic model, the backbone of modern navigation used by airplanes, ships, smartphones, and military systems. Normally revised every 5 years, the model now requires revisions every 12 to 18 months. As if the Earth's magnetic heart is skipping beats, resetting its rhythm beyond prediction. What's more unsettling is the symmetry. While the North Pole dashes toward Russia, the South Magnetic Pole is accelerating in the opposite direction, a mirror movement never before documented in geological records. Satellite data confirms that the magnetic field over the South Atlantic is weakening at a rate of 5% per decade, while it's inexplicably strengthening over Siberia. Wildlife is paying the price. Arctic terns, birds that migrate tens of thousands of miles annually, are arriving at the wrong locations, disoriented by invisible forces that once served as their celestial compass. Whale strandings have surged in magnetically unstable regions. Even seismic activity appears to be reacting to the shifting field as fault lines awaken in unexpected places. And deep within the Earth, strange pulses called magnetic jerks emanate from depths once thought inert. These pulses, regular yet mysterious, occur every 6 to 8 months and seem to align with no known natural process. It's as if the Earth's core is sending coded messages, misunderstood by our instruments, but persistent nonetheless. The implications ripple outward. Earth's magnetic field is our shield against solar radiation and cosmic particles. As the field weakens and reorients, pockets of vulnerability emerge, allowing increased radiation to seep into the atmosphere. Airline pilots have reported navigation failures over regions like northern Canada, where magnetic interference can cause compasses to misread by up to 20 degrees. This isn't theoretical, it's operational and increasingly dangerous. For centuries, geomagnetic reversals were thought to unfold slowly over thousands of years. But the behavior we now observe unfolds in months, years, in real time. It challenges fundamental understandings of planetary magnetism, and with it the assumption that Earth systems evolve gradually and predictably. What if they don't? What if the forces beneath our feet and above our heads can pivot on timelines far shorter than we believed? What if the Earth's magnetic field is not a stable compass rose, but a living, dynamic entity, one whose patterns we are only beginning to recognize? As we follow the poles in their unpredictable race, we're left with a question far older than any map. What else in Earth's deep machinery might shift while we're looking the other way? It began in the sky, over the Sahara, where rain should be a rumor, not a reality. In 2023, meteorologists observed something that wasn't supposed to exist. A river, not on the ground, but in the air. A narrow, dense corridor of moisture stretching thousands of miles across the desert. Atmospheric rivers are usually born above oceans, fueled by evaporation, carried by wind. They don't form over dry land. And yet, this one did. It carried enough water vapor to rival 20 Mississippi rivers. The images from satellites were undeniable. Over the central Sahara, a ribbon of dense moisture arched overhead, persistent and structured. But that wasn't the strangest part. The vapor didn't dissipate as it should over hot, arid terrain. Instead, it strengthened. It gathered weight. And then it fell, dropping inches of rain in hours onto a landscape that hadn't felt such downpours in decades. Traditional atmospheric science could not explain it. The air should have been too dry, the surface too hot. There was no ocean nearby to feed it. No jet stream to steer it. Yet this river in the sky had defied all the rules. Scientists scanned the data again. Moisture levels were at 250% of what should be possible at those temperatures and pressures. The vapor held on well beyond the point of expected condensation. The Clausius-Clapeyron equation, the very law predicting how moisture behaves in the atmosphere, had been rendered meaningless by what was unfolding. And it wasn't an isolated event. Across landlocked regions, deserts, plateaus, mountainous interiors, these impossible atmospheric rivers began to appear. They moved with eerie coherence. They carried isotopic signatures that didn't match any known oceanic water sources. It was as if the rain had come from nowhere, or from someplace we hadn't thought to look. These phantom rivers defied meteorology, but they also hinted at something deeper. Within them, radar detected electrical pulses unlike any typical storm, signals resembling the fingerprints of technology more than nature. Their internal temperatures remained stable despite conditions that should have forced condensation. And when they reached specific geographic coordinates, they released their burden in full, not over time, but in sudden torrential bursts. Some began to wonder, could the sun be involved? Solar flare activity, normally considered a space weather concern, seemed to precede the formation of these rivers by 24 to 48 hours. That timing repeated, too regularly to ignore. Could the sun's electromagnetic emissions be influencing atmospheric water in ways we haven't yet understood? And what of the water itself? Chemical analyses of the rainfall revealed isotopes that didn't belong. Signatures never before recorded in the global water cycle. It was water that seemed new, ancient, or entirely foreign. A kind of ghost rain, unanchored from known sources. These observations tear at the seams of our scientific frameworks. If deserts can suddenly host oceans in the sky, if moisture can behave as if drawn by unseen forces, then what else have we missed? What forces might be shaping the climate beyond temperature and carbon? As we look to the skies for answers, one truth becomes clear. Even the most arid landscapes can become frontiers of the unknown. And perhaps the laws we thought governed the weather are only part of a larger, stranger story, one that flows like these rivers from somewhere beyond our current reach. It was once the ocean's most reliable current, steady, vast, eternal. The Gulf Stream, flowing along the Atlantic coast of North America, has been a planetary metronome for thousands of years. Carrying warm water from the tropics toward Europe, it regulates weather, stabilizes climates, and shapes ecosystems on both sides of the ocean. But since 2019, something unthinkable has been happening. It began with a subtle drift. Then entire sections of the current began to reverse direction, not just briefly or locally, but over months and hundreds of kilometers. Warm waters that should move northward were sliding south and still holding their heat. Oceanographers were stunned. The principles of thermodynamics, fluid mechanics, and planetary rotation all said this couldn't happen. But it was. Vast eddies, swirling vortices of warm and cold water, formed spontaneously, spinning in the wrong direction for the northern hemisphere. These weren't minor fluctuations. Some were the size of small states. They persisted for months, ignoring all established models of Coriolis force and momentum conservation. Nothing in the textbooks accounted for this. Dr. Stefan Rahmstorf, a leading climate scientist, documented full reversals lasting up to 6 months. He called it a rebellion, the ocean overturning its ancient choreography. And the chaos spread. Sea surface heights began fluctuating in ways decoupled from winds, tides, or gravitational forces. Tropical fish appeared thousands of miles north of their natural range, surviving, somehow, in waters that should have been too cold, too acidic. Deep ocean instruments recorded synchronous changes at depths of 3,000 meters, where stability had once been a given. Then came the most puzzling signals. Acoustic current profilers recorded flow speeds and patterns that required energy far beyond what wind, heat, or pressure could supply. These reversals weren't just passive responses. Something was driving them. Could it be the sun again? Satellite data showed a correlation between solar storms and ocean current anomalies. Within 12 to 36 hours of geomagnetic disturbances, sections of the Gulf Stream changed course. Was electromagnetic energy affecting the ocean's deep circulations? Marine life noticed before we did. Plankton blooms shifted weeks before instruments recorded changes. It was as if ecosystems were tuned to a deeper frequency, responding to signals science couldn't yet hear. What does this mean for the future? The Gulf Stream is more than a current. It's a planetary circulator, distributing heat, shaping weather, buffering extremes. Its disruption could unravel familiar climate patterns. Cold Europe, drought-stricken tropics, frozen coastlines where once there were warm breezes. But beyond the climatic implications lies a stranger question. If the oceans are reacting to invisible, Perhaps cosmic forces. Are they part of a system more interconnected than we imagined? Perhaps the sea is not just a body of water, but a sensor, feeling, responding, relaying the shifts of a planet in flux. And perhaps beneath its waves lies a record of changes that started long before we noticed and will continue long after we catch up. Beneath the frozen silence of the Arctic lies a paradox, one that shouldn't exist. Permafrost, by definition, is ground that remains frozen year-round. It is Earth's cryogenic vault, sealing away ancient carbon, methane, and even remnants of prehistoric life. But now, something unprecedented is happening. In some regions, permafrost is thawing rapidly. In others, just miles away, it's thickening and expanding. Sometimes both occur at the same site, simultaneously. At a borehole site in Alaska, scientists recorded surface layers warming at alarming rates. But deeper down, the same instruments showed cooling, even within the same column of Earth. This inversion defies basic thermodynamic laws. Heat should move downward or upward in predictable gradients. But here, it's dancing in patterns that no model can replicate. And the soil is changing too, shifting, cracking, groaning. Some areas slump like melting wax, while others heave upward as if swelling from within. Ground-penetrating radar shows the boundaries of frozen and thawed layers shifting by tens of meters within a single day. Not season, day. Then there's the methane. In known thawing zones, methane emissions are skyrocketing, up to 100 times above expected levels. But nearby, other zones are absorbing carbon dioxide, even nitrous oxide, with no discernible biological mechanism. These chemical contradictions, emissions and absorption in adjacent areas, don't line up with temperature, organic content, or microbial activity. They simply don't line up at all. Core samples deepen the mystery. In some, organic matter is decomposing far faster than expected. In others, it's becoming more stable, like it's retreating into preservation. Radiocarbon dating, the gold standard of geologic timelines, is breaking down. In certain cores, surface materials appear to be thousands of years older than layers beneath them, flipping time itself upside down. From space, thermal imaging reveals even stranger patterns. Satellites register temperatures that don't match ground-based sensors. A region that appears frozen from orbit may be thawing at the surface, or vice versa. It's as if the permafrost wears a mask, hiding its true condition from the instruments watching above. What could explain this? Some have suggested unknown energy sources. Electromagnetic surveys reveal conductivity patterns that shift independently of moisture or temperature. It's as if the soil is undergoing phase changes beyond the classic ice-to-water transition into states we don't yet understand. Meanwhile, seismic monitors detect microquakes in permafrost zones, suggesting structural changes too rapid for normal thermal expansion or contraction. This isn't just an Arctic story. It's a revelation that the Earth's frozen ground is not passive. It's dynamic, volatile, and increasingly unpredictable. For those who study climate, the implications are vast. Permafrost was thought to be a tipping point, a slow, ominous thaw releasing greenhouse gases in a steady cascade. But what we're witnessing is not slow. It's erratic, self-contradictory, possibly orchestrated by forces not yet in our scientific vocabulary. If the Earth's coldest ground can warm and freeze at once, if time itself seems to misalign within the soil, then perhaps what lies beneath isn't just permafrost. Perhaps it's a reminder that even in the most silent, inert places, change can erupt, sudden, strange, and without warning. Look up, not just into the night sky, but into the electric shell that cradles our planet. The Ionosphere, a band of charged particles stretching 50 to 400 miles above Earth, has long been our silent partner. It reflects radio signals, shapes auroras, and shields us from solar radiation. For decades, scientists believed it danced to a single rhythm, the sun's. More solar energy, more ionization. Less sun, less charge. Simple, but now simplicity is unraveling. In recent years, the ionosphere has begun to generate electrical energy that outpaces solar input by staggering margins. During periods of mild solar activity, instruments have recorded ionospheric charges thousands of times stronger than the sun alone could create. The energy has no identifiable source. It's as if the sky has started generating electricity from within, violating the very principle of energy conservation. High-frequency radar systems, like those used by Europe and other atmospheric research stations, have captured plasma formations that defy natural behavior. Triangular, hexagonal, and rectangular shapes hover in the ionosphere, persisting for hours in turbulent conditions that should shred them in minutes. These aren't the random dances of ionized gas. They're structured, geometric, intentional. Then there's the heat. Incoherent scatter radar, some of our most precise atmospheric tools, shows that certain ionospheric layers are heating and cooling without regard for solar cycles. Some zones maintain elevated temperatures of 2,000 to 3,000 Kelvin even when the sun is quiet. According to known physics, there is no source for that energy. None. Lightning on Earth has begun to echo this strangeness. Electrical storms are forming in dry air in cloudless skies. Ground stations detect electromagnetic pulses from the ionosphere, signals that resemble artificial radio transmissions. They have patterns, modulation, and timing sequences. But no transmitters. GPS systems are suffering too. Positioning errors in supposedly stable regions now exceed 10 meters, disrupting aviation, logistics, and emergency services. These aren't random glitches. They follow consistent patterns, suggesting coordination, not chaos. Perhaps most chilling is the connection to Earth itself. Earthquake activity has been found to precede or follow ionospheric disturbances. Within hours of deep tremors, the ionosphere shifts, sometimes before seismic waves even reach the surface. This suggests a feedback loop between ground and sky, between geophysics and electromagnetism that science cannot yet explain. And if the ionosphere is responding to forces deeper than we can see, what else might be listening? What other layers of the planet, or beyond it, might be engaged in this silent exchange of energy? The ionosphere has always seemed remote, the edge of space, out of reach. But now it feels closer, stranger, more alive. It pulses with signals we don't fully understand, defies heat equations, ignores the boundaries we thought divided Earth from cosmos. In its flickers and surges, it may be telling us something, that Earth is not merely a ball of rock and weather. It is a web of energies resonating from crust to cloud to the outer reaches of the sky. And the patterns we see, however unfamiliar, may be the language of a planet still writing its story. There are places on Earth where gravity itself refuses to behave. Gravity, the invisible force that holds planets in orbit, tides to the shore, and our feet to the ground, is perhaps the most fundamental of physical laws, unyielding, predictable, universal, or so we believed. But in a growing number of locations across the globe, gravity is fluctuating in ways that challenge both Newton and Einstein, not by imperceptible margins, but by measurable, repeatable amounts. In these so-called gravity anomaly zones, instruments record changes in gravitational acceleration up to 200 microgals within 24 hours, levels that should require the sudden movement of billions of tons of subterranean mass. And yet, seismic data shows no such geological activity. The land is quiet. The rock is still. But gravity shifts. At first, scientists suspected errors, equipment malfunctions, environmental interference. But the anomalies appeared across continents, measured by independent teams using separate instruments. Precision gravimeters, atomic clocks, satellite altimetry, all confirmed the same impossible truth. Even more unsettling is their coordination. Gravity anomalies have been observed to occur simultaneously across vast distances, synchronized like a planetary heartbeat. From Asia to South America, from polar regions to the equator, localized gravity fluctuations appear and vanish in concert without any known cause. According to all gravitational theory, this is impossible. Gravity is local, tied to mass, tied to density. It shouldn't echo across oceans and continents, but it does. And the effects don't end there. In these anomaly zones, atomic clocks tick differently. Time itself dilates beyond predicted margins, as if space-time is being locally stretched. Ocean tides behave erratically, diverging from the lunar and solar patterns that have guided them for eons. Weather systems become unstable. Temperature inversions form without warning. Winds shift direction against pressure gradients. It's as if these regions are being touched by an unseen hand, nudging gravity, bending time, rewriting the invisible script that holds reality together. Underground surveys add another layer of mystery. Borehole gravimeters show mass distributions that don't match geological expectations. Some regions appear to gain or lose density over days, a geological impossibility. Even the core samples taken from these areas conflict with what gravity measurements suggest should be present. Perhaps most intriguing of all is the shape of the fluctuations. Mathematically, they resemble signals, oscillating patterns with frequency and modulation, more akin to radio waves than random geological noise. This has led some to wonder, are these gravitational anomalies natural, or are they responses, echoes of something else? In controlled environments, laboratory experiments have detected gravity-like fluctuations in sealed chambers, isolated from electromagnetic interference. The results are controversial but consistent. They suggest that what we call gravity may not be as stable or as fully understood as once thought. If gravity can flicker, if time can bend, if space can pulse in localized bursts, then we are not living on a passive rock orbiting the sun. We are standing on a planet still in the act of becoming, still shaped by forces deeper than any textbook has described, and the ground beneath our feet, steady as it seems, may be far less certain than we've ever imagined. Lightning without clouds, thunder without storms. Energy from a sky gone rogue. Around the world, Earth's electrical behavior is shifting in ways that upend our most basic understanding of atmospheric physics. For centuries, we've believed lightning is the result of storm clouds, water droplets, ice crystals, friction, and towering cumulonimbus formations building enough charge to snap the sky in half. But now, lightning is emerging from clear skies. In regions with relative humidity below 30%, where storms should be impossible, sudden electrical discharges have been documented. Massive bolts arcing across cloudless air, unleashing billions of joules of energy without any visible storm cell in sight. These aren't freak accidents, they are increasing in frequency. Some areas report lightning activity up 25% year over year, even as rainfall declines. The anomalies deepen with measurement. Electric field mills and magnetic loop antennas have recorded elevated atmospheric charge levels persisting for hours, long after lightning has struck. Ground current flows, typically short-lived in conventional storms, have been measured lasting half a day or more. The air remains electrified. The energy somehow doesn't dissipate. And then there's the sound of intelligence within the storm. Radio frequency detectors, part of global lightning networks, have picked up signals embedded in these discharges, regular pulses, structured frequencies, and timing patterns that suggest non-random behavior. Some of these resemble the signatures of man-made radio transmissions. But they originate from nowhere. No towers, no satellites, no sources within human reach. Even more eerie, these electrical events are happening simultaneously across continents. Thousands of miles apart, discharges occur in tandem, as if choreographed. No shared weather systems connect them. no jet streams. Just a shared rhythm, a pulse moving through the air, unbound by geography. The Earth's global electrical circuit, once a background hum, is now screaming. Voltage measurements show the entire system operating 50 to 100% higher than historical baselines. Ball lightning, once dismissed as folklore, is being observed more frequently. Not for seconds, but for minutes. These glowing spheres drift across fields and roads, holding their form, even showing directionality, as though guided by something. In laboratory conditions, the chemistry doesn't add up either. Samples of air taken during anomalous storms show ozone production and nitrogen fixation at rates far beyond what known lightning can achieve. It's as if the lightning itself has changed, or is being enhanced by energies we haven't yet identified, and above the ionosphere mirrors the chaos below. Electrical surges, pulses, and patterns appear to couple with events on the surface. Changes up there seem to ripple down here, a feedback loop of unknown origin, linking Earth's surface to its upper atmosphere in ways we never modeled. What does it mean when lightning no longer needs clouds? When air alone can carry and sustain currents that rival the fiercest storms? It suggests the atmosphere has become something more than weather, something alive with energy, sensitive to forces beyond our sight. Perhaps electrical storms are no longer just meteorological events, but windows into Earth's deeper energetic state. And perhaps in these bolts from the blue, the planet is signaling a shift, not in weather, but in the very laws that once defined what the sky could do. Imagine standing in a place where your compass suddenly spins, then stops, pointing in the opposite direction it did just hours before. Across several regions of the globe, Earth's magnetic field isn't just shifting, it's flipping. Not over thousands of years, as geomagnetic theory predicts, but over days, sometimes hours. These are not full planetary reversals like those recorded in geological history. These are hyperlocalized magnetic flips. Sudden polarity changes spanning 500 to 1,000 square kilometers, occurring with such speed and precision that satellites have to update magnetic coordinates in near real time. Dr. Monika Korte and her team at the German Research Center for Geosciences documented one such event. Within 24 hours, compass readings in a northern region of South America reversed by 180 degrees. Morning and evening measurements told two different stories. No solar flare, no geomagnetic storm, no tectonic shift. Just a silent, dramatic inversion of Earth's magnetic whisper. And it's not just instruments noticing. Migratory birds, sea turtles, and whales that rely on magnetic cues are losing their way. GPS-tagged animals have been recorded veering hundreds of kilometers off course. Some never return. Some strand themselves on shores, disoriented, as if their internal maps had been erased and redrawn overnight. Proton magnetometers show fluctuations of 5,000 to 15,000 nanotesla, changes that should require planetary-scale core disturbances. But geological sensors detect no such internal upheaval. It's as if these magnetic reversals are happening independently of the Earth's molten iron engine. Worse still, they're coordinated. Satellites from the European Space Agency's Swarm constellation have detected these rapid magnetic flips occurring at multiple global sites, often within minutes of each other. This level of synchronicity defies randomness. It suggests influence, or communication between distant regions of the magnetic field. Electromagnetic surveys show currents flowing beneath these zones that don't align with Faraday's laws. In many cases, the currents appear to cause the magnetic flips, not the other way around. That reverses everything we thought we knew about electromagnetic induction on a planetary scale. These local flips also disturb space-based systems. GPS readings skew. Radio communications falter. Even low Earth orbit satellites adjust their orbits in response to the magnetosphere's warping behavior. Archaeologists are now re-examining magnetic dating techniques. Artifacts buried for centuries are showing magnetic orientations that don't match known records. In some cases, modern materials are reading like ancient ones because their surrounding magnetic environment changed so radically and so recently. We are forced to ask, what is the magnetic field really? Is it a stable dipole tied solely to Earth's spinning core, or is it more like a web, flexible, reactive, and influenced by layers of interaction still hidden from our understanding? When the compass turns against its maker, when direction itself becomes a question, we're left with an unsettling truth. The forces we trust to guide us may be far more dynamic and far less predictable than we ever imagined. And if the magnetic field can flip without warning, without cause, and without consequence, what else can change in the blink of an earthly eye? It should be one of the most dependable rhythms in nature, the rise and fall of atmospheric carbon. Each year, like breath, the planet inhales and exhales. Plants absorb carbon dioxide in spring and summer. In fall and winter, it returns to the air. The cycle is precise, predictable, a cornerstone of climate science. But now, that cycle is breaking. In recent years, atmospheric carbon levels have begun to fluctuate erratically, rising and falling by 15 to 40 parts per million in mere weeks. These shifts are far too rapid for the slow processes of photosynthesis, respiration, or fossil fuel emissions. They defy the logic of biology, industry, and seasonal rhythm alike, and the anomalies are spatial as well as temporal. Carbon sensors placed across varying terrains, forests, cities, deserts, are detecting wildly different concentrations over short distances, even when vegetation and human activity are held constant. One tower may report a spike in CO2 while a station a few miles away records a sharp drop. The atmosphere, it seems, is no longer behaving like a well-mixed reservoir. The deeper mystery lies in the signatures. Isotopic analysis of these carbon spikes reveals ratios of carbon-13 to carbon-12 that don't match any known source. Not fossil fuels, not volcanic activity, not biological respiration. Some of the carbon appears alien, not in origin, but in behavior. It's as if parts of the atmosphere are tapping into reservoirs we haven't discovered, or responding to processes we can't yet define. Oceans, too, are acting out of sync. In places where atmospheric CO2 is dropping, ocean carbon levels are rising, violating Henry's law, which governs gas exchange between air and water. It's as if ocean and atmosphere are dancing to separate beats, connected by some unseen conductor. Soil carbon measurements add to the puzzle. In some regions, underground carbon content changes by 20 to 50% over a single month. Microbial activity can't explain it, nor can plant growth. The soil is taking in, or releasing, carbon faster than biology should allow. Even plants are acting strangely. Eddy covariance towers, which measure gas fluxes between vegetation and the atmosphere, show uptake and release rates that exceed the known limits of photosynthesis. To account for these rates, plants would need to process carbon 10 to 100 times more efficiently than measured in any laboratory. And then there's the nighttime puzzle. CO2 levels are shifting during hours when photosynthesis doesn't occur, changing in the dark when plant carbon exchange should be at rest. It implies that something beyond the biosphere is influencing the flow of carbon. Modeling these changes breaks the rules. Mass balance equations fail. Carbon seems to appear or vanish without warning, defying conservation laws that have long been the foundation of environmental science. If we cannot trust the carbon cycle, the very pulse of planetary metabolism, then what can we trust? Perhaps carbon, like gravity or magnetism, is part of a more complex system, one that reacts to forces we've yet to map. A system where Earth's breathing doesn't just follow sunlight and seasons, but deeper, hidden tides. And if the planet is changing how it breathes, what might it be trying to say? It began with silence, a quiet that wasn't supposed to happen. Seismologists noticed it first. Earthquake zones, long known for their restless energy, went still. Major fault lines sat dormant for months, defying statistical expectations. Meanwhile, other regions, historically stable and quiet, began to shake. In central Australia, eastern Canada, and the American Midwest, tremors of magnitude 6.0 and higher began appearing where no active fault systems exist. According to plate tectonics, these places should not move. The crust is thick, ancient, and unstressed. And yet the ground quaked. Dr. Seth Stein, a geophysicist from Northwestern University, called it impossible seismicity. But it didn't stop. Deep within the Earth, even stranger things stirred. Earthquakes were detected at depths beyond 600 kilometers, zones where rock is too hot and pliable to fracture. Yet waveforms showed brittle failure, sharp, sudden, as if the rock had forgotten how to bend and simply broke instead. Even the rules of stress and strain are unraveling. Earthquakes are exceeding magnitudes that known tectonic forces should be able to produce. Aftershocks don't follow expected decay patterns. They emerge in pulses, often in regions disconnected from the original quake, as if the energy is spreading through an unseen network rather than along physical faults. Seismic wave velocities are shifting too. Signals that once took predictable paths now arrive early, or late, or not at all. It suggests that Earth's interior, once thought stable over millennia, is changing on a timescale of months or even weeks. And then something truly puzzling: synchronization. Earthquakes began occurring in clusters across multiple continents within 24 to 48 hours. There was no geological link, no shared fault line, but they moved like a wave, energy cascading not through rock but across the planet itself. It resembled global resonance, not local rupture. What could connect these distant events? Some point to electromagnetism, others to gravitational anomalies. A few suggest the Earth's internal energy systems, heat, charge, pressure, are coupling in ways we don't yet understand. Whatever the mechanism, traditional models can't keep up. Forecast accuracy has dropped sharply. Entire regions defy categorization. Places long dismissed as geologically inert now host seismic swarms. Meanwhile, familiar danger zones fall into eerie stillness. It's not just the strength of earthquakes that's changing. It's their behavior, their timing, their logic. As if tectonic plates are no longer the sole players in this global symphony. As if the Earth is reconfiguring not just its surface, but its internal choreography, shifting the rules beneath our feet. We once believed that earthquakes came from slow pressure buildups and sudden releases. But what if something else, something more dynamic, is animating the planet's movements? And what if the silence before the quake is not a lull, but a whisper of change, spreading far wider than we ever imagined? The sky above the desert should be dry, still, predictable. But in recent years, the impossible has unfolded overhead, not just once, but again and again. Imagine atmospheric rivers, narrow bands of water vapor capable of carrying more moisture than the Amazon, forming over arid lands thousands of miles from any ocean. These rivers, once thought to require deep oceanic evaporation and coastal winds, are now appearing over the Sahara, Central Asia, even the American Southwest, not drifting in from afar, forming there. They are vast, stretching thousands of miles, yet often only hundreds wide, and they don't behave like traditional moisture systems. Instead of dissipating over dry land, they intensify. Satellite imagery shows these vapor corridors gathering strength over parched soil, carrying water where no source should exist. In 2023, one such river dropped over 6 inches of rain on the central Sahara in less than a day. Rainfall that would typically require storm systems fueled by oceanic heat. Yet no such system was present. Meteorological models, grounded in hydrodynamics and atmospheric thermodynamics, failed to predict it. They simply had no precedent. The anomalies go further. Within these sky rivers, instruments detect moisture levels exceeding 250% of atmospheric capacity based on temperature and pressure. According to the Clausius-Clapeyron equation, the vapor should have condensed long before reaching land. Instead, it holds form, as if gravity, temperature, and pressure are playing by new rules. When precipitation does occur, it happens suddenly and completely. Vapor converting to rain within hours, not days, as if triggered by invisible switch points on the Earth's surface. Some locations become instant flood zones. Others, just miles away, remain untouched. And there is structure inside the chaos. Radar reveals electromagnetic activity unlike anything seen in natural storm systems. Signals pulse through the rivers with patterns more akin to technology than weather. Atmospheric pressure readings show gradients that defy hydrostatic equilibrium, as though something is actively maintaining the flow against the laws of physics. These rivers also seem to respond to the sun, but not through heat. Solar flare activity, not radiation levels, appears to precede their formation. Within 24 to 48 hours of increased solar electromagnetic output, new atmospheric rivers begin to appear. This pattern holds across continents and seasons. And the water? It carries secrets. Isotopic analyses of rainfall from these events reveal compositions that don't match oceanic or terrestrial sources. Some carry water molecules with isotope ratios suggesting origins outside the known hydrological cycle, as though they've bypassed evaporation altogether. If true, it would mean these rivers are pulling water from reservoirs not yet mapped, perhaps not even on the surface of the Earth. These phenomena challenge more than meteorology. They challenge our understanding of how Earth breathes, drinks, and moves moisture. They suggest atmospheric systems are being influenced, perhaps orchestrated, by forces we don't yet comprehend. And if rain can fall from a sky fed by no ocean, guided by no wind, and governed by no rulebook, then perhaps we are witnessing not a weather anomaly, but a message written in vapor. One that says, the atmosphere is not a passive stage. It is a player in its own right, one that may hold secrets still unfolding above our heads. Earth is whispering in a language we are only beginning to hear, through patterns, pulses, and movements that blur the lines between disciplines, systems, and senses. Take the planet's magnetic poles, sprinting across the globe. The Gulf Stream, once steady, now reversing. Or permafrost thawing and freezing at once. These aren't isolated freak events. They're converging signals. And the closer we look, the more they seem to move together. Climate, magnetism, ocean currents, atmospheric electricity, seismic activity, each long studied in isolation, are now misbehaving in tandem. What once took millennia is now happening within months. Satellite data shows magnetic field strength weakening over South America while strengthening over Siberia. At the same time, gravity anomalies appear in those regions, disrupting atmospheric pressure systems and weather formations. Earthquakes erupt in seemingly stable continental interiors, just as the ionosphere above them surges with unexplained electrical charges. Are these mere coincidences, or signs of a deeper, system-wide reorganization? Science has long treated Earth systems as separate engines, climate driven by carbon and sunlight, tectonics by heat and pressure, weather by air and moisture. But these anomalies suggest a more complex architecture, an interconnected web where change in one thread vibrates through the whole. Consider the timing. Solar activity, long thought to affect only the upper atmosphere, now appears to ripple into ocean currents, permafrost behavior, and even atmospheric river formation. The sun flares, and within 48 hours, rivers of vapor bloom over deserts, magnetic poles accelerate, and gravity itself shifts. Not always, but often enough to notice, often enough to question. And what of biology? Plankton respond to ocean current changes before sensors detect them. Migratory birds deviate from ancient paths in regions of magnetic instability. Marine mammals strand themselves in zones where gravity, magnetism, and sonar all misalign. It's as if life is attuned to changes we don't yet understand, sensing disturbances in Earth's fabric we cannot yet. In the end, it's not just about anomalies. It's about awareness. We have journeyed through a planet unraveling its own secrets: magnetic poles that sprint, lightning that strikes from clear skies, gravity that flickers, and rain that falls from air without oceans. Each chapter has revealed a rupture in what we believed was fixed, a crack in the lens through which science has long viewed the world. But beneath the bewilderment lies a deeper invitation, not to fear the unknown, but to rediscover it. For centuries, we've organized nature into systems: atmospheric, geological, hydrological, biological. We've built models and drawn borders, made predictions. These tools have served us well. But what if the Earth was never so neatly divided? What if these categories were conveniences, not truths? What we now witness suggests a convergence, a moment when the hidden relationships between Earth systems begin to show themselves, not as isolated breakdowns, but as coordinated transformations. It's not simply that the magnetic field is changing, or that earthquakes appear in unlikely places, or that permafrost behaves erratically. It's that they are all happening together, and in that unity of change, a new picture of the planet emerges, one that pulses like a single organism, not a machine, but a being. One whose systems are not separate engines, but harmonics in a symphony we are just beginning to hear. The implications are as philosophical as they are scientific. If gravity can fluctuate like weather, if the atmosphere can channel energy as if guided, if water can fall from skies unlinked to oceans, then perhaps the boundaries between sky and soil, magnetism and life, matter and energy, are more porous than we believed. Perhaps Earth is not merely reacting to external forces, but expressing internal rhythms we've never truly known. This doesn't mean we abandon the frameworks of science. It means we deepen them, enrich them, invite mystery back into the method. Embrace uncertainty not as failure, but as frontier. Because at its heart, science is not about certainty. It's about wonder made rigorous. And the wonder is everywhere. In whales navigating by invisible lines that shift beneath their fins. In lightning tracing patterns no storm ever taught it. In soil that breathes carbon in ways plants alone cannot explain. In sky rivers that defy thermodynamics. In clocks that tick differently where gravity bends. These are not flaws in the planet's function. They are glimpses of its depth. So where does this leave us? With more questions than answers. But better questions. Deeper ones. Human ones. What if Earth is alive in ways we've forgotten how to see? What if we are not just passengers on a spinning rock, but part of its unfolding story, threads in its changing fabric? And what if, in these anomalies, the planet is not breaking, but becoming something new? The future of understanding won't be found in firmer conclusions. It will be found in more courageous curiosity. In listening closely, in asking again, because the Earth is speaking, and at long last we may be ready to hear it.